Welcome to Critical Thinking for Ecosystem Science. I'm Dr. Tom Stolgren. This is Lecture 3 on Knowledge, Belief, and Evidence. These are loosely adapted from Schick and Vaughn's textbook in 2010. Let's start with some definitions. Knowledge are facts, information, and skills acquired by a person through experience, education, or evidence. Belief is an acceptance that a statement is true or that something exists without evidence. And evidence is the available body of facts or information indicating whether a proposition is true or valid. Let's take a sample proposition that all wildfires in Colorado are caused by UFOs. There is good reason to doubt a proposition if it conflicts with other propositions we have good reason to believe. That is, if there's stronger evidence for them. Well, we have some evidence that human beings and lightning cause most wildfires. Newspaper reports, direct observations, and then after-the-fact investigations. We have many arsonists that have been caught and convicted. That says something to be convicted. And a fire expert may have personally witnessed lightning starting several wildfires. In fact, several fire experts would claim this to be true. But suppose a UFO expert comes in and says, well, UFO rocket ships and flying saucers have massive afterburners that catch grass fires wherever they go. Or a priest may say it's God's will that there are wildfires and appeal to faith. That UFO expert can turn back to you and say, you know deep down inside that there must be UFO afterburners because the grass is obviously burnt and there's no one around, as you can see. That's an appeal to intuition. But taken together, the evidence is overwhelming that humans and lightning cause most wildfires. No other alternate explanation seems reasonable. Let's look at astrology one more time. What's your sign? Did you read your horoscope today? Well, simple observations tell you that a lot of people under the same sign behave differently. So maybe a sign doesn't exactly correlate to human behavior. Observations might also suggest that all artists are not born under the same sign. So people with the same behavior aren't necessarily all Gemini or all Leos. More importantly, studies have shown that when 90% of respondents are given the same horoscope, the very same horoscope, they say that it matches to them very well. 90%. What does that tell you? Well, it still tells you that 25% of Americans believe in their horoscopes. I can't explain it. But let's think about the difference between belief and knowledge. A belief, again, is an emotional attachment to an idea. Knowledge is an awareness of the evidence of an idea. Belief requires no evidence, and knowledge requires no belief. Now, some philosophers don't see it this way. Some say that knowledge is the combined effects of our beliefs and the truths that are out there with whatever evidence we gather. I tend to think, like the previous slide, that beliefs are different. They're the acceptance of an idea without any evidence. God, heaven, astrology, ESP, UFOs, Bigfoot, palm readers, the tooth fairy, ghosts, and other entities would fall into my category of beliefs. And I see this is a link to pseudoscience, where hypotheses are actually based on beliefs. It's an attempt to add credibility and certainty to ideas weak in evidence. Astrology, ESP, creationism, UFOs, or intelligent design. And I personally tend to put science as testable hypotheses in a category by itself, leading to knowledge with reasonable uncertainty. Knowledge of evidence of ideas such as evolution, natural selection, laws of thermodynamics, theory of relativity, and other laws, based on the scientific method. That's how we gain the information and gain our trust in ideas. So again, I see a difference between science and non-science. On the non-science side, we have all sorts of things that many of them cannot be tested directly. On the science side, we gather evidence all the time. We're open to new ideas. We could admit being wrong, and it's self-correcting. Geology, astronomy, chemistry, physics, and biology, medicine. Let's take a look at the age of the Earth. Now, I'm pretty confident that radiocarbon dating by several methods and by several different scientists have shown that the oldest rocks in West Greenland, for example, are 3.7 to 3.8 billion years old. The rocks in Africa, West Australia, and the Great Lakes have shown to be about 3.6 billion years old. The oldest dated minerals in Western Australia are 4.0 to 4.2 billion years old. Moon rocks, which was originally part of the Earth, are found to be 4.4 to 4.5 billion years old. You see, the numbers are starting to coalesce. And the majority of 70 well-dated meteorites have ages between 4.4 and 4.6 billion years, those meteorites found on Earth. We now have fairly good scientific evidence that estimates the age of the universe to be somewhere around 14 to 17 billion years. Now, there's still some uncertainty in there, as you might guess, but we know that the age of the Earth is probably not 6,000 years old. And as we gather more evidence, besides radiocarbon dating, endosymbiosis, the number of other creatures that live on us, mites that attack little bacteria on our face, or stomach organisms that help us digest food, we are really part of a group of organisms. In a modern synthesis of ideas that includes speciation, mutations, DNA, modern evolutionary development, and genetic similarities between us and other life forms like chimpanzees or other mammals or even plants, we have a distant relative. Well, that's pretty convincing that the age of the Earth is somewhat older than might be stated in, say, the Bible. In fact, if we just look at human evolution, we see a very nice coherence to Darwin's theory of natural selection. Earlier human types have changed forms, small evolutionary changes that have given us an adapted advantage over previous types. And this is very important. So, learning to walk in a bipedal way 6 to 2 million years ago, and then adding certain types of teeth, picking up tools, working tools, creating fire, and moving on the evolutionary scale, we have adapted these new techniques and new bone structures and so on to make us more competitive in the world around us. And that we can trace through time very well with fossils. So the evidence for evolution is overwhelming. I won't go into everything on this chart, but I hope you find this chart with the link down below and study it very carefully. It's the kind of evidence from a variety of viewpoints that together give us more proof in the evidence for evolution. And on the other side, the evidence against evolution, well, we're not finding that much evidence against evolution with thousands of new studies each year. Taken together, we have strong evidence for evolution. The reason I say this is because science demands hard evidence. And there just isn't the hard evidence available for some claims. We have to consider, as we'll learn later, how to test ideas. Is it really testable that we've had a 7-day creation? How would we test that? Why 7? Why not 8? Why not in 4? How would we ever test that? The fruitfulness of creation. Well, does it predict new phenomena? Did it predict hybridization? Scope. Does it really help explain diverse phenomena? How about the fossil record, DNA overlap, or carbon dating? Doesn't really help explain those other lines of evidence. Simplicity? Well, if it's a major assumption that one super powerful being did it all, it's going to be hard to disprove that, isn't it? And conservatism, well, that would be entirely inconsistent with all the other evidence that we find in support of evolution. So, in a sense, science requires hard evidence. And the reason I'm telling you this is that you're at a great disadvantage in the world of ecosystem science if you don't come from a starting point of accepting some of the major evidence from all the studies in the past. We know, for example, that roots are supported by ectomycorrhizae and that create nitrogen nodules in nitrogen poor ecosystems. They evolve that way. We know that different substrates, different soil types and substrates sometimes produce different vegetation types on top of them. We know that some pollinators have co-evolved with certain plant species, and yet other pollinators are generalists. Over time, we have to see what the effects of humans are on a system, how we've altered the wildlife, the soils, the vegetation, and the entire landscapes. And unless you have a clear idea of evolution and history on a site, it's going to be much more difficult trying to figure out your study results. So I'll leave you with this, a little story about how the Earth changes over the long term. And I thought a nice way to tell this story is with an Ice Age documentary, How the Earth Was Made. So in your copious free time, I'd like you to take 43 minutes out, it's worth every second, and take a look at this video that tells you a little bit more about the Earth in time. And it gives you a real sense for how dynamic this world we live in is. Thanks.